Hi guys. So today we're going to go over question 6 from the paper 1 of the 2015 exam. And so these financial maths questions, they can be very daunting because there's a lot of writing in the questions, but once you break it down to the relevant maths, they're actually quite nice, these questions. So Dunna is arranging a loan and is examining two different repayment options. Bank A will charge him a monthly interest rate of 0.35%. Okay, monthly interest rate of 0.35%. Find correct to three significant figures. Okay, three significant figures. The annual percentage rate. Okay, so the annual percentage rate that is equivalent to a monthly interest. Okay, so that is equivalent to this monthly interest rate. Okay, so what are they giving us? So our interest I is 0.35%. And we know that this is, as a decimal, 0.0035. Always just move the decimal place 2 to the left. Okay, so now let's try and think about this. Say that he starts with 100% of his loan, so 1. Okay, he starts with 1. Okay, after a month, this has gone up 0.35%. So 0.35% of 1 is just 0.35%. So this has now become 1 plus 0.0035. Or equivalently, we can just write this as 1.0035. And now after 2 months, this has become 1.0035, and then adding 0.35 of that. So plus 0.0035 by 1.0035. And so we can kind of group these terms, and this will give us the common factor by 1 plus 0.0035. Okay, well we actually know what this second term is. It's just, again, 1.0035. So it's actually the equivalent of just multiplying the current amount by 1.0035. So we start with 1. It becomes 1.0035. And then it becomes 1.0035 squared. And then, as you can imagine, this just keeps going on. So after a year, it has multiplied by 1.035 12 times, or equivalently, 1.0035 to the power of 12. And so this is how compound interest works. So we've gone from 1 to 1.0035 to the power of 12. And what is that? Well, that is 1 has become 1.042818. 0.42818. Okay. So that's an increase of 0.042818. So the 35%, the 0.35% a month is equivalent to, if he had just over a year, just paying 0.042818 immediately, which is 4.28% yearly. Now remember, it's three significant figures. So three significant figures are 3 digits after the zeros. Okay, that's what the significant figures are. So non-zero figures. Okay, so that's our answer. 4.28%. Alright, so Bank B will charge him a rate that is equivalent to 4.5%. Okay, so we know that he probably should go with Bank A because it's a lower APR. So find correct to three significant figures the monthly interest rate. Alright, so again, let's identify. Equivalent in APR 4.5. Again, three significant figures, the monthly interest rate that is equivalent. Okay, so again, we've got annual equals 4.5%. So after a year, it's gone from 1 to 1.045 because this is 0.045 in decimal. All right, so we're going to have a similar approach to this. We're just kind of going to go in backwards. So we've got to think, so let's say if we knew the monthly. We know that the monthly to the power of 12, which we kind of look at, the monthly to the power of 12 gives you your yearly. Okay, so let's call our monthly I. Let's call it IM. Okay, so our 1 plus our monthly, 1 plus IM to the power of 12 gives us our yearly. That's what we did in the first thing. We have 1 plus our yearly, 1 plus our monthly, which is 0.0035 to the power of 12 gives us our yearly. Okay, so 1 plus IM to the power of 12, our 1 plus our monthly to the power of 12 should give us our yearly. And we know what our yearly is. Our yearly is 1.045. Okay, so now we have one variable that we do not have and everything else is here. So we're going to take both sides to the power of 1/12. We want to get the IM by itself. Now this is kind of the same thing as, let's say squaring a square root. So if we take this as 1 plus IM to the 12, and this whole thing to the 1/12, then this will equal this to the 1/12 to the 1/12. Okay, well, these two are just going to cancel if you remember our rules of indices. So now we've got 1 plus IM is 1.045 to the 1/12. And what is that? 1.045 to the power of 1/12. And this equals 1.0036748. 1.0036748. Okay. Well, now that very easily allows us to find IM. And IM then would be 0.0036748. Okay, and so what? And that is equal to 0.367%. Remember, three significant figures. And so now we have our monthly. 0.367%. Okay. Okay, so now we're going to look at part B of this question. So Donna borrows 80,000 at a monthly interest rate of 0.35. Okay, so we picked Bank A, which is fixed for the term of the loan from. Okay, the loan is to be repaid in equal monthly repayments over 10 years. The first repayment is due 1 month after the loan is issued. Calculate, correct to the nearest euro the amount of each monthly repayment. Okay, so this is one of the harder financial maths questions that they're going to ask you. So let's just try and break it down. So he borrows 80,000 and the monthly interest rate of 0.35, which is fixed. The loan is to be repaid in equal monthly repayments over 10 years. The first payment is due 1 month after the loan is issued. Calculate, correct to the nearest euro, the amount of each monthly payment. Okay. The amount of each monthly payment. Alright, okay. So what are they immediately giving us? So the loan is 80,000. The interest rate, I, equals 0.0035 monthly. And it's over 10 years. So, over 10 years. Okay, so equal monthly repayments. Equal monthly repayments. Over 10 years. So 120 months. Let's actually just write it like that. Over 120 months. Okay, so let's say that equal monthly repayment is P. Okay? Let's call it P. P is our monthly repayment. And this is what we're trying to solve for. So, the way to think about this is, let's say we pay them P after 1 month. What is that worth to the bank? Okay, so after 1 month, we pay P. We pay P euro after 1 month. Well, there's an interest rate of 0.0035. Okay? So, what by that interest rate would be equal to P? So how much it's worth to them, let's say the value to them, V, is, V to the power of, by 1.0035, the value to them is what we're paying them. Because they've set the interest rate to be 0.0035. Okay? So, how much value are we giving them? We know we owe them 80,000. So, this V is equal to P over 1.0035. Let's call this V1 just because it's the first month. So this should take V1 off of the 80,000 that we owe them. So what would it be after the second month? Well, V2, well, because it's gone over 2 months, this would be 1.0035 squared equals our P. So our monthly payment is worth P over 1.0035 squared to them. That's what it's worth to them. In the same way, V120, the value of our last payment is, well, it's the amount over this compound, because our monthly payment after 10 years is not worth the same. It's not worth the same as it is today. So this is why it's worth less. So we know that the value that we give them has to equal 80,000. That's how they get their money back. That's how it's worth it for them. So the sum of the values, so V1 plus V2 plus all the way up to V120 is equal to 80,000. Okay? Now this is a tricky question. There's no getting around it. It's a tricky question. But I think that this is probably the best way of thinking about it that makes it easy to understand. And there's only so many difficult questions they can ask you with regards to financial maths. If you understand the kind of thought process behind this, it should be very doable if one comes up in your own exam. So this sum is equal to 80,000. Now we have expressions for these variables. So we can rewrite this as 80,000 equals P over 1.0035 plus P over 1.0035 squared plus all the way to the value of the last payment. $1.0035 to 120. Okay, now we've got a sum of terms that are getting smaller by the same amount each time. Now, what does this look like? Well, it sort of looks like a geometric sequence. So if we have 80,000, well, this equals P over 1.0035 by 1 plus 1 over 1.0035 plus dot 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 plus 1 over 1.0035 to 119. Because if you remember, we already took one count of this out. Okay. And we have a formula for this. So our formula is the sum equals A times 1 minus the ratio to the power of n all over 1 minus the ratio. So our A is just 1. Our A is just this guy. And then our ratio is just this guy. And then we've taken out a factor here. So we can just put that back in. So 80,000 is equal to P over 1.0035 all by 1 minus the ratio to the n. So one minus, and n is 120. There's 120 terms here. 1 over 1.0035 to the power of 120 all over 1 minus 1 over 1.0035, our ratio. Alright, so if we put that into the calculator, then we'll get 1 minus 1 over 1.0035 to the power of 120 over 1 minus 1 over 1.0035. And this will equal 98.19. So we have 80,000 equals P over 1.0035 by 98.19. And then we can just multiply by 1.0035 and divide by 98.19 to isolate P. So eventually we get P equals 80,000 over 98.19 all multiplied by 1.0035. And this gives us a monthly payment of 808,17598, or rounded to the nearest euro, 818 euro. And now this is a tough question, and the most important thing, there's kind of two tricks. Understanding how to write this expression, and then realizing that it's a geometric series. But these types of questions all look very similar. And so once you understand how this one is done, then you'll understand how all the others are done.